Good afternoon, everybody. Stats students, we have reached the end. So now we are. So I am super excited for where we're at, and we are going to look today at the free response section and kind of some strategies there, and also the formula sheet. Okay, so okay, are we back? Are we back? Okay. I do apologize, everybody. I'm seeing myself now, and everything looks normal. Um, all right, awesome. Okay, that was weird. I just had to refresh my Vimeo page um, to make sure that things were going. It's like everything was working but Vimeo, and I was trying to go in and adjust the settings, and nothing in Vimeo would load. I could go to any other website I wanted to. So okay, good. We're in business now. Awesome. Sorry about that, everybody. Technology sometimes. I had to change internet connections. We have two internets at my house currently. We're swapping over to a new internet, which has been great. And then today it just decided to not be great. So I had to go back to our old internet, which rarely is great. But having two networks was very helpful right now. So I'm glad I haven't canceled the second one. So anyways, today we are going to jump in and look at two things. We're going to look at the formula sheet for AP Stats, because that's a really big deal. And then we are also going to look at the free response. Basically, in a nutshell, as I went through the 260-page course and exam description and picked out the most important parts. Okay, all of the streams were built off of that when we went through units 1 through 9. And then the study guides are built off of that as well. But then also the extra stuff, things about the exam, I've kind of pulled out for you for today's stream. Okay, so always, you know the drill. The name in the chat, if I refer to you, make sure that's generalized if need be. We've seen the video from Amanda on getting on Facebook and our Facebook, Twitter, TikTok, Instagram, all the socials, and Fiveable has some awesome incentives for you, showing your creativity and your love for Fiveable. So we've seen that video a few times now.
What up, AP students? It's Amanda here from Fiveable. We are literally giving away $100 to pay for
with the technical issues we had. All right, so there are the socials. Make sure you tag them if you do that, and there's also some hashtags to include in your TikTok or your Instagram, your Twitter, whatever it is that you put out there for your creativity. Make sure you tag Think Fiveable, and I think it's hashtag YesWeCram is the hashtag they're looking for. It's on my water bottle that I use. All right, so this is insane. So normally we have always had coming soon events, and we are at the point in the semester, everybody, where we have one event left, and it is the big one, the 5-hour cram finale, Sunday, May 16th at 1 p.m. Eastern Time. That is 12 p.m. Central Time, 11 p.m. Mountain Time, 10 p.m. Pacific Time. And anything outside of that, I'm sorry, I don't know those time zones. So we are going to go through that. I've been finishing things up over the past few days, getting ready for that stream. And I think it's going to be very, very valuable to you to help you in preparing for your exam on the next day, the 17th. Okay, so again, today we're going to look at the formula sheet and then strategies for free responses and what you can expect to see on that free response section. Okay, so if we're going through the formula sheet, let me just pull that up here to kind of show you what it looks like. I'm a little bit nervous about swapping scenes after the issue that we had. Okay, I think it did that just fine. So if you're looking at the formula sheet, this is the one that was published online for last year. It's the same. It might have some more graphics to it, but it's going to be the same layout. You have kind of these different sections here for formulas and things like that. And then you have your Z-score, T-score tables towards the end. Okay, so we're going to kind of break it up into sections and look at those different things. So the first section we have is for descriptive statistics and regression. Okay, so the first two were mean and standard deviation, and we really just use those formulas the way we've always done mean, add them up and divide by how many, and then standard deviation, we just kind of do it in the calculator. You're not going to be asked to do one of those by hand. But some important things to note on the regression section, okay? Anytime you're writing out a regression equation, make sure you put the hat on the y. I also instruct my students, instead of writing y and x, write the context of what it is, okay? So maybe height with a little hat over the word height, because it's the predicted height, and then instead of x, in parentheses, write the word weight or whatever, you know. I know there was a question with height and weight of wolves a few years ago, so use context instead of x and y, and your y is always, always, always predicted, okay? The y... Another way you can find parts of the regression equation is if you take the average of all the x's and the average of all the y's out of your data set. And then that will line up with your linear regression equation. It will have the same slope and go through that y-intercept. The slope, which is the b value, which I know is confusing because in Algebra 1 you do y equals mx plus b, but the slope is the b value because they do your initial value plus the rate of change is kind of the way we treat it in stats. Another way of finding that is if you take the r value, your correlation coefficient, and you multiply it times the standard deviation of y divided by the standard deviation of x. That product will give you the y-intercept, okay? Don't worry about the R formula, okay? You're not going to have to do that by hand. You also probably won't even have to do it in the calculator Normally, the R value is either given and you interpret it, which we'll definitely talk about this week a little bit and next week, or you'll be given the R squared value, in which you do a little bit of algebra, take the square root, and then once you take the square root, make sure the sign to your R value matches your R squared value. Okay? So that is, that formula is on there, and it's highly, highly unlikely that that's going to show up. So don't concern yourself with that very much. So that's kind of the first section of the formula sheet. So other types of regressions. Nah. In AP Stats, we only look at linear regression. Okay? There is a super, super small chance that you might have something that's non-linear, in which case, if it's non-linear, you can take the natural log of all of the y's and all of the x's, and it more so makes it a little bit more linear. But that you're talking maybe one multiple choice question, okay? And if you remember what I just told you, you probably could pick the right answer choice, okay? So it's just not worth our time. We're looking for the biggest bang for our buck, and that's one of those small areas on the exam that's just not going to be there, okay? Yes, this will be recorded. It will be. All right, so the formula sheet, the next part is probability. Okay, remember the U means union, so it also means or. So if you're trying to find an or probability, you can take the probability of A and add it with the probability of B, and then subtract the probability of A and B. Think about if you're looking at a two-way table, you can take the total for event A happening and the total for event B happening, you know, one on the columns and one on the rows, and then you subtract the overlap as one strategy of finding that, and that's what this is coming from, that subtraction. Now, what's probably going to show up sometimes on the multiple choice, they will give you just generalize, here's A, here's B, find either the and or the or, and you work out using this formula. You plug in here, you plug in here. If A and B are independent, remember the and probability is the product of the two, but they have to be independent. And then you have the conditional probability, which also can be used to find the and probability, the intersection, if you work it backwards. If it tells you the conditional probability and tells you the probability of B, then you can work that problem backwards by putting an X in for the probability you're looking for. Okay, so those formulas mainly just come in handy on multiple choice, I mean maybe a free response as well, but where it just gives you generalized probability of A, probability of B, you can plug into the formula and work it out using some basic algebra. Okay. Again, the multiplication rule, so A times B is equal to A and B. That only works if events A and B are independent. They're given to you that they're independent, or the context of the problem leads you to know they're independent. You know, if event A is getting a heads on the first coin flip and event B is getting a heads on the second coin flip, then those are independent. They're not affecting each other any. So you could assume that the probability of one times the probability of the other is the probability of both happening. Okay. So somebody tell me what's the problem with this. Okay, we got this nice meme. I tried to put some memes in here to break up the text. That was kind of some feedback that I got, which I definitely agree with. So what's the problem with doing a binomial distribution if there are three outcomes? Barks Root Beer, sponsor of AP Statistics Cram sessions. Not really, I wish they sponsored. Someone got me that for Teacher Appreciation Week this week. So what is the problem with a binomial distribution with three outcomes? Yes, exactly, Cody. It is binomial because it only has two outcomes. So think binary, like in computer science. It's either a 0 or a 1, okay? So a binomial distribution has to have a success and a failure, which I also see that in the chat showing up. So yeah, if there's three outcomes, if there's a yes, no, and a maybe option, it's not binary, okay? There's no clear success and failure. There's three options. Okay, so then there are some things about a binomial probability that are important. Now remember, binomial, it is binary. There's a fixed number of trials. All the trials are independent, and they're all equally likely of happening. So if you wanted to find the mean of a binomial distribution, okay, how much you would expect, it's also important you start thinking about mean also as expected value. So how many, if a rocket is launched successfully 10% of the time and you launch 50 of them, well, how many would you expect to be successful? And it would be, here's your formula, N times P. 10 rockets times a 50% chance times 0.5, which would be, you would expect 5 of the 10 rockets, okay, which makes total sense. And then if you wanted to add a standard deviation to that, there is your formula for standard deviation, the square root of N times P times 1 minus P. So that is when you have a random variable X that is binomial. You also have the binomial formula for a binomial PDF problem. To be honest, we use the calculator. That's the way I've always approached it, because you're more than likely going to need a calculator to do the binomial coefficient, the combination in X, and if you have a calculator to have to do that part of the formula, you might as well just let the calculator do the whole formula for you at once, because we do have that option. Okay, so again, the four qualities. We already mentioned those: binary, independent of each other. There's a fixed number of trials. That's important, and we're going to adjust that in just a second. And all trials are equally likely. Okay, if those four are met, then your probability distribution that you're looking at for a particular random variable, and particularly a discrete random variable. So like a normal curve is a continuous random variable. A binomial is typically a discrete. You have set numbers that it's going to fall into. Again, the mean is also referred to as the expected value. Now, before we go into this next one, it's just a slight adjustment from binomial. What is the one difference for a geometric distribution in terms of the conditions that make it binomial or geometric? The formulas are definitely different as well. Yes, in the chat I see no fixed number of trials, and that is exactly right. That is the difference. So on your formula sheet, this is what you're given. Okay, so your formula for this one kind of makes sense. Okay, basically geometric is you're looking for the probability that the first success comes on the X trial. Okay, so basically you're going to fail X minus 1 times, and then you're going to succeed the X time, the last time. So there's your formula, okay? If there's a 10% chance of success, the probability that your first success comes on the 5th trial would be 0.9, 1 minus 0.1, to the, when I say 9th trial, to 9 trials. So it would be 8, because you're going to fail 8 times, and then the 9th time you finally get that success, okay? So then it would be times 0.1. So 0.9 to the 8th power times 0.1. And that would be the probability of getting a success on the 9th time. Your formula is 1 divided by P. All right? So you would expect there to be success 1 divided by P. That's when you would expect to be that first success. And then the standard deviation is the square root of 1 minus P divided by P. And you're doing something until you get a success. All right, so let's just touch base with our formula sheet real quick. We'll swap back over there real quick and just kind of see where we're at. So we have made it through section 2. So we have really the mean and standard deviation. I mean, we know how to find the mean. You add up and divide by how many there are. This is just fancy pants math formula for that. Standard deviation typically is in the calculator. It would take you 20 minutes to calculate something like that by hand. Therefore, they're just not going to give it to you. The other stuff we talked about, kind of the specifics, and then the probability section. So now we're going to look at the inference section. Which is very important. Okay, so your standardized test statistic. What are the 2 main standardized test statistics that we have talked about in AP statistics? You can throw those in the chat. Z and T, exactly. All right, so the formula for a Z-score and a T-score are the exact same. All right, I know that's just mind-blowing, but the only thing that's going to be different is that your standard error, that part of your formula is a little bit different, okay? But you're basically going to be doing the observed value, which is your statistic, because it's from a sample that you actually have the numbers for, okay? So observed minus expected, which is your population parameter. You would expect it to match your population, which is the big picture that we really don't know a lot of times, okay? So observed minus expected and then divided by the standard deviation. This is your formula for a Z and a T-score. Those show up on multiple choice all the time. The formulas where they're blank and not worked out, not solved out, so you can't just do it in the calculator. You got to know the parts. And we're going to look at those for sure next week, okay? But that formula is really valuable because the standard errors all come in on the next page of the formula sheet. Observed minus predicted divided by standard deviation. Or if you want to simplify your formula knowledge, it's the actual data minus the predicted data divided by standard deviation. So just like residuals that you had in Unit 2 with regression. Okay, actual minus predicted, AP statistics. I love this. I'm going to start using this when I have students come to me. Hey, Mr. Argo, what's my grade right now? You know, and you know, students, and I'm sure I was guilty of this as a student as well. I feel like sometimes they think that teachers just keep a running total in their head of everybody's grade, and they know their grade book memorized anytime to the other. And most of the time, the only students that I really know what their grade is are the ones that are low that I'm really trying to work with to bring up. So yeah, that's the look on my face a lot of times, and I'm like, listen, I'm 100% confident that it's somewhere between 0 and 100, but that's about as much as I can tell you. And normally I can say between 65 and 100, you know, because I know they're a higher level student if I don't know their grade. All right. So then that's the confidence interval formula, which is also the same regardless of what type of confidence interval. You take your statistic, which is your observed value, okay? If it's a difference of 2 proportions and means, you'll see proportion 1 minus proportion 2 in parentheses. Same thing with T-score. You might see that on top, and then your expected is 0. So it'll be, you know, your difference in your 2 sample proportions minus 0. Sometimes they don't even print that, divided by that standard deviation. So that sample statistic, plus or minus the critical value, which is your Z-score for proportions, your T-score for means, and then times the standard error. That is the same formula for all confidence intervals. Okay? Again, multiple choice. I know this is more of a free response stream, but that format is going to show up. You pick the confidence interval I mean, you could do it in the calculator and then work out all the answer choices, but that's not a really good use of your time. So I wouldn't recommend that. And then remember, if you see the words margin of error, that is everything after the plus minus sign. Okay, that's the whole kit and caboodle. The standard error is just the standard deviation formula that you'll see on the next page. The margin of error is the two things combined. Okay, your chi-squared test statistic is for multiple proportions. Observed minus expected squared divided by expected. You'll see that expanded out a lot. Make sure the last number matches the bottom number. We talked about that last weekend. Make sure those match, and make sure that they're in the right order. Observed minus expected divided by expected on all the pieces of your summation. All right, clearly we cannot have a chi-squared value that is negative because all of our observed minus expected values are being squared. Since they're all being squared, then they all have to be positive. And then we're adding up a whole bunch of positive numbers. Okay, so if you get a chi-squared that's negative, hate to break it to you, you did something wrong. Okay, typically you're either getting it from a calculator for a test, or you're going to see it expanded out, and you have to pick the right one. I see in the chat, what is the best way to identify when it's going to be chi-squared? If your data is given to you as it's a proportion problem, so it's categorical data, and it's given to you in like a one-row column, multiple categories of one variable, that's a chi-squared goodness of fit. When you are given a two-way table and it is from one sample, that is a chi-squared test for association. When you are given a two-way table and it's taken from two separate samples, that is chi-squared test for homogeneity. Can't ever say that word right. Southern accent's not helping on that word. So yeah, that really sums it up. Categorical data, one variable with multiple categories, or two variables, like a two-way table. Two-way table, one sample, test for association. Two-way table with two samples, so one of either the two rows or the two columns, that is from different samples, is test for homogeneity. All right, so actually going through inference, is that confidence interval formula again? Okay, these are your statistics over here on the left. Okay, so you take your, well, it's actually the p-hat over here, I guess. So you take your p-hat, that's where you start, and then you add or subtract your critical value, either your z or your t-score, which if it's proportions would be a z-score, times the standard deviation. Okay, these two, it would be this one for confidence interval. Because we don't know a p, we do know a p-hat. Okay, so here and here. And when you get to inference, when you assume the two things are equal, then you'll use this one. You'll combine, you'll pool your data. Okay, so this little chart, and the chart we'll see for means in a minute, can be pieced together to build this formula. Okay, statistic is your p-hat. Standard error is your standard error. Critical value is your z-score, which I will show you how to find on the chart in just a minute. Okay. Same thing for means. You take your x-bar, start out there. You add and subtract your critical value, which will be your t-score. I'll also show you how to find that. Times your standard error. It's a one sample mean, take this one. It's a two sample mean, take that one. You never pool means. You pool proportions for hypothesis tests, you never pool means. Okay? So there's no caveat there to the standard error. All right? So those are the components you should see in those multiple choice broken down questions. And it's really easy from the formula packet. Okay, let's go. I'm going to show y'all the formula sheet, what I'm talking about. All right, so to find so that's really mostly all of the formula packet. We're not going to look at the slope stuff. It's just very few questions, And with our limited time and more bang for our buck, we're just kind of glazing over that a little bit. We know degrees of freedom is 2 for calculating your t-score. And then we know how to conclude a p-value that's given to us accordingly. Your null is always the slope of 0. You conclude your p-value the same way, okay? And if there is a low p-value that for your slope, that means that there is a correlation, all right? So, all right, so we have our z-score table. If we can calculate the z-score, then we can find the tail probability. Okay, we've done that a little bit. We typically use normal CDF to find that probability, or inverse normal if we know the probability and we're solving backwards, which is what we're doing for confidence intervals. But believe it or not, the t-score chart is what's very helpful here. Okay, so you can look at the bottom and it tells you the confidence level. So if I'm doing a 95% confidence level, 95% confidence interval, I'm going to use this row right here. Okay, because the tail probability is 2.5%. 2.5, 2.5 makes 5%, which is the complement to the 95. So if I'm doing a t-test and I have a sample of, say, 25, well, my degrees of freedom is going to be 24. So 95 at 24, that would be my critical value for my confidence interval. Okay, so that is how you would do it for a t-interval for means. Find your confidence level and work your way up to the correct degrees of freedom. Now, here's the really cool thing. If you are doing a z-interval for a proportions, this bottom row here, the infinite degrees of freedom, is a z-score. All right, which you probably know, 95% confidence interval, the critical value for that is 1.96, which is an infinite degrees of freedom. So if you're doing a proportions, that bottom row here is going to be your critical values. Can't see around my mic there. Okay, so that bottom row is your z-scores for a confidence interval. All of the other ones are t-scores based off your degrees of freedom, which is sample size minus 1. Okay, that just makes things a lot easier for those multiple choice questions. You don't have to remember how to go in and do inverse norm, inverse t, and do that type of thing. You can just look at the formula sheet. Yes, you do get the formula sheet for both. I'm 99% confident of that, Sander. Last year was so different testing at home that it's just been a while. So I'm almost positive you get it for both sections. Like 99.9% sure, okay? All right, cool. So let's go back to the slides. Now let's talk about the free response discussion for the free response section. So what I did was I went through the course and exam description. All right, it's like 205 pages. A lot of it is the course of study. It's the things we need to learn for AP statistics. Okay, it tells us what we need to know. And then after that, it has some like teaching strategies, blah, blah. It has the formula packet, and it has some things about the exam. What's going to be on the exam? Of course, it tells you there's 40 multiple choice for 90 minutes and 6 free response, 5 of which are normal, and 1 of which is the investigative task, number 6. But then it goes into more detail now, and we used to not have this. And now we have this. And I was talking to our calculus teacher today. If you took AP Calculus, my thoughts are with you. That test was a beast earlier this week. I looked at the FRQs today. And they don't get this in calculus. They don't get this breakdown of what the questions are going to be on. And in stats, we do. We are guaranteed that one of our free responses is going to be on collecting data, experimental design, random sampling, bias in sampling, things like that. Okay, we're guaranteed to have something on that. That's Unit 3 in the course exam description. You are guaranteed to have one on exploring data, which is pretty certainly going to be univariate data like cussing the data, drawing a box plot or a stem and leaf plot, which we'll go into all these things again in a minute, or a bivariate data, which is that scatter plot with computer output where you are interpreting the values, maybe calculating a residual, things like that. So you're guaranteed to have that. And it breaks it down even further on the next few slides. You are guaranteed to have one on probability. That's units 4 and 5 in the CED. It could be on sampling distributions as well. And I've got some common ideas and breakdowns of questions based off of that focus, okay? You are guaranteed to have one on inference. You will have a state plan do conclude somewhere on there. If it's hypothesis test, my guess is that you are only going to have to do the hypothesis test. If you have a confidence interval, you probably will have a part B that's kind of like an extra little algebra, maybe something about how you would conclude that confidence interval, if, was this value contained in the interval, something like that. And then you have one question, so that's 4. 4 of them we know exactly what they're going to be on. And then you have one that's kind of multiple categories, and it's going to have inference in it. Inference will be there somewhere in that 5th question, whatever the order is. I feel like in the past, the first 2 have been swapped, and then 3 is probability, 4 is inference, 5 is the kind of random stuff. And then you have your investigative task. There's no way to predict what that's going to look like. Generally, it has 3 components it's graded on. One of them is something that you've done and it's familiar, and if you're well versed in AP stats, you should be good with it. And then the other 2 are things where you are having to analyze and kind of go the extra mile of like, I've never done this before. In 2019, it was a bootstrapping method, not in the AP stats curriculum. But your understanding of stats and analysis of stats should give you the option. You should have the know-how of going that extra mile and figuring things out, okay? But it's typically a very difficult question. And it is the fact that it's not very predictable. You can practice those on your own. You can access them through AP Classroom, I think. And there's plenty of other resources as well. But it's so hard to predict that it's hard to really know what's on there. But we'll talk about that more as we go through. But we know 4 of our 5 free responses, we know exactly what they're going to be on, okay, which is, kind of nice. There shouldn't be surprises. Now, this is the first year we've tested with the CED, so there could be surprises, but they have told us that. So, you guys are awesome. It is Friday afternoon. You are hanging out, cramming for AP Stats. I'm pretty confident you're going to be there on the Sunday 5-hour cram stream as well. Y'all just needed to know that you're awesome. You're going to be just fine. You're doing the right thing. You're in the right place. You're going the extra mile. Take some deep breaths this weekend. Me and my wife are going to the beach for a few days, which is going to be really nice to kind of decompress before we go into that last little push before the AP exam. So, take some time for yourself this weekend. You are awesome. All right, anyways, just a little break there. So that first question, it says 1 free response question will primarily focus on exploring data, assessing some combination of skills 2A, 2B, 2C, or 2D. All right. So what I did is I flipped back, all right, and went back through the CED and found those skill descriptions. And these are the way it's kind of laid out. Normally in the past, and I have had people who have read for the AP exam who have confirmed this theory of mine, that is normally number 1 on the exam. It's typically the easiest free response, takes the less amount of time, and it's usually on describing data, exploring data, okay? The most common thing you would see is asking you to cuss the data. So either describe distributions or to compare distributions. Okay, so it gives you a box plot or a histogram or a dot plot and says describe the distribution of blank, whatever the context is. So make sure whenever you describe those, use approximately words. The center is at about 15 miles traveled, okay? The center is approximately 15 miles traveled. Some sort of wiggle word. You don't want to be too exact in AP Stats, which is Kind of silly, especially if you're coming from AP Calculus, where if it's not rounded to 3 decimals, then you get docked. Okay, if you have 2 dot plots or 2 histograms, you want to compare those. The center of this one is at 15, which is larger than the center of the second distribution at 12. Make sure you include context. That's a really common thing I would expect you to have. Kind of the other option. Okay, I feel like it's one or the other based off of those skills. The second one is interpreting a scatter plot or the computer output. Study the interpretations for slope, y-intercept, r squared, standard deviation of the residuals, all those things. Those interpretation, kind of those can statements are important. So unit 1 or 2, probably where number 1 on your free response is going to come from. Include context on all of these. Also, that one of these skills, okay, I think it was 2C maybe, was be able to construct a graph. 2 years ago, which was in a way a precursor to the CED and the new way of doing AP Stats, the new curriculum, if you want to say that. Number 1 had a question that asked you to construct a box plot. It gave you a grid and it gave you the 5-number summary and said construct a box plot from this data. Okay, which most everybody got that. It was pretty simple. You know, your minimum, your Q1, your median, your Q3, and your maximum. And there were no outliers, so you didn't have to worry about outliers. Some other options is a stem and leaf plot. If you're asked to construct a stem and leaf plot, make sure you include the key with some context. So something like, I'll put it in the chat, 2, tall line 5 means 25 miles traveled for work. Okay, so make sure you put that key at the bottom of your stem and leaf plot if that were to be something you were asked to do. Okay, also remember, this was a common mistake 2 years ago, the box plot doesn't have anything to do with mean and standard deviation. The box plot is just that 5-number summary, Q1, or minimum, Q1, median, Q3, and maximum. Okay, and then it also shows outliers if you happen to have those. Label your axes on a histogram. So if you're doing like if you're drawing like, you know, a bar chart, label your axes, your scales. Okay, and that's also how you would put context, is by labeling that. Also know how to find summary statistics, the mean or the standard deviation by calculator or by hand. Use your L1, one variable stats, pretty much does it. Okay, so stat, edit, and then stat, calculate, one variable stats. All right, also know what will happen to certain things if you remove a value. So that could be from a scatter plot. What happens if I take this value out? Okay, maybe it takes that that regression line and it tilts it down. So that makes my slope less. Okay, say if I took out this top point up here and it's going to tilt my line down, it's going to make my okay, because your sum that you're adding up is now different. Whereas median sometimes is not affected. Mean is not resistant to outliers. Median is resistant to outliers. Median is not going to be affected by an outlier. A mean is affected by outliers. Okay, so that is number 1. I really think very, very likely that number 1 on your exam on May 17th will be very, very close to one of those two things. Scatter plot and interpret, maybe remove a data point, or, you know, here's a histogram, describe the distribution, here's some more things about the data, create a stem and leaf plot or box plot. How would the stem and leaf plot change if you took this value out, added this value, etc. Okay. Think that's going to be number 1. I would suggest doing number 1 first. Kind of get your feet wet a little bit, get comfortable in the exam. Hopefully give you a little bit of confidence moving forward. Different strategies. I would do number 1 first. Okay. So number 2, usually number 2, the numbering, it could be different. They don't say that number 1 is going to be this, number 2 is going to be that. But historically, experimental design has shown up as the second question. Okay, that was skills 1B and 1C. Yes, thank you for correcting me in the chat. The median is resistant to outliers. I was thinking in my mind affected. The median is resistant. It is a resistant measure of central tendency. And then the mean resistant. That was a good catch there. Okay, so median is not going to be changed by an outlier. And the mean will be changed by an outlier. Okay, good point there. Thank you for pointing that out. So experimental design, usually number 2, again, that's purely speculation and based off of previous patterns. But you'll have one on experimental design. The numbering may be different. Be prepared. This is one, oh man, like, gotta know this. Gotta know this. Even on years where there wasn't a whole free response dedicated to this, this question snuck in there somewhere. Know the difference in an observational study and an experiment. Okay? That is the treatments. Were treatments randomly assigned? If so, that's an experiment. Make sure in your description there you specify which treatments that were randomly assigned. A few years ago, there was a question on, does smoking explain Alzheimer's? Smoking was your response or explanatory variable. Alzheimer's was response. And the question, it was just right out there, is this observational study or an experiment? And the answer was, it was an observational study because you cannot assign smoking treatments to people. That's unethical. And my students all over the place were guilty of saying observational study because treatments were not randomly assigned, which is 100% true and 75% right. But you have to specify, was it the Alzheimer's treatments that were not randomly assigned, which clearly that doesn't make sense. But it was the explanatory variable that was not randomly assigned. Okay, that question sneaks in there all the time, even on years where there wasn't much on experimental design. The next thing, be able to identify bias, like a volunteer thing, where there are volunteers in the study. Which way is that going to bias it? Is it going to make the results sway to the left or sway to the right or whatever? So be able to identify that. So identify the bias. Don't worry about necessarily the words you call it, response, non-response, sampling. Just be able to explain why it's biased and then tell me which way it's going to sway things. It's going to make people more likely to lean this way or that way. Identify the explanatory and response variables. Make sure you give like a clear option. So like the smoking and Alzheimer's, if you just said smoking and Alzheimer's, that was only partial credit. But if you said something like number of cigarettes smoked, where there was a quantity assigned to that, and if you said acquiring Alzheimer's or not, so like the two options, then you were, smoking or not smoking, so that that kind of binary aspect of it, then you got full credit. But just saying smoking Alzheimer's was only partial. So assign some quantity to that random variable, to that explanatory variable, or a binary status. Be able to discuss sampling methods. How are you going to create a random sample? The hat method, a random number generator, we talked about those back in Unit 3. Those are important. Make sure you mix up the hat if you do the hat method. Be very clear in your explanations. Think about, you're not writing this to your stats teacher that knows that you know. You're writing it to someone who has never met you before, cannot read your mind at all. You are just a number to them. You're not even a name. And be sure you're very clear. Be sure like you could hand explain how to create a sample. You could hand it to a 12-year-old and they could read it and then they could go and produce that sample. They could say, oh yeah, I can write everybody's name on a hat and put it in a hat and mix it up and pull out 5 names. Okay, make sure it's very, very clear on how you would randomize those studies, on why it's biased, etc. So that's number 2, I think. That's the second question. The next question is on probability. Again, it's typically number 3. Probably number 3, pun intended. Be familiar with sampling distributions. They throw that in there, okay? It says focused on probability and sampling distributions. Okay, so remember, sampling distributions have three conditions: random, independent, and normal. Normal is different for proportions and means. Remember, there are three things that we would describe a sampling distribution with: center, spread, and shape. If you are asked to describe a sampling distribution, those are the three things you're going to do. And the reason why is because of those three conditions. The center of my sampling distribution is your true population mean or proportion. The reason why is because it's based on random samples. Spread is standard deviation, which is on your formula sheet. All right. I'll pull it up real quick. Formula sheet. There's your standard deviations, all right here. Okay, so if you're asked to describe a sampling distribution, here's your center, your population proportion or mean. Here's your spread, and the reason we can use that is because of that independence condition. Reasonable to believe that our population is 10 times the sample size. Okay, so center, spread, and then your shape for a sampling distribution is almost always going to be approximately normal because of whatever normal condition you have. Means n greater than 30, sample size more than 30. Proportions np greater than or equal to 10. Remember, two proportions, you got to pull them together for that condition. Okay. So if you're asked to describe a sampling distribution, it is the same thing as describe a distribution. You got to talk about the center, shape, and spread. You don't have to do outliers because it's more than likely approximately normal. But those two questions are asking the same thing, just a little bit different route in taking those. And those three things, the CSS for a sampling distribution, hinges on those three conditions that we do throughout the whole last half of class. So then a lot of times once you get that sampling distribution described in part A or B, then you might have to use normal CDF to calculate a probability of getting a sample of a given size. Okay. The only thing that's going to change for a normal CDF with a sampling distribution is your standard deviation is going to be smaller. Label your calculator speak. If you're asked to define a random variable, I was in a training a few years ago, and that was pushed really strongly. So I kind of remembered that heading into this first year of CED testing. And so yeah, just write something like let X equals the number of hikers on the Appalachian Trail. Okay, X equals, if it says define the random variable X, X equals the number of some sort of quantity attached to it, yada, 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 blah, blah, blah. Okay, be familiar with binomial probabilities, the four conditions. Again, if you're using binomial CDF or PDF, label your calculator speak. Be familiar with geometric, not fixed trial, same as geometric, also label calculator speak. Okay. Know how to solve probabilities from a two-way table. We talked about that back in Unit 4. That's another common option for that probability question. If it asks you if two events are independent, they are independent if the probability of the first event is the same as the probability of the first event, given that the second has occurred. Usually you're using previous answers and comparing part A to part B. If they're equal, independent. If they're not equal, not independent. Also, little precursor to number 4, the second question, is a probability for maybe part B is lower than 0.05. That's where that reason to doubt kicks in. Remember, that's where the P is low, you drop the null. Okay, P is low, you drop the ho. P is low, you reject the null. Okay, so that is kind of, again, where that reason to doubt kicks in. That's a common question. That's a way they'll kind of tie an inference in with a probability question. You might calculate a probability off of a binomial or geometric or a two-way table, and then you use that probability to essentially conclude an inference test. know how to fill in a probability distribution table, and find the expected value. We are going to touch on that next weekend. I've made it a point to bring that together. All probabilities add up to 1. Expected value is the outcome times the probability, and then sum all those together. All right, so those are different probability. That one has a lot of routes it can go because basically half of the course hinges on probability. I would say in the past 10 years, probably 8 of the 10 are from those things that I just mentioned. Okay, I can think of several years where there was a question tied to one of those things we just talked about. All right, and number 4 is just the straight up inference. Either create and interpret a blank confidence interval, or if it asks you to estimate the true mean or proportion, that's going to be a confidence interval. Or the also famous, probably going to show up, do the data provide convincing evidence, or is there convincing evidence at the 0.05 level, 0.10 level, etc. Okay. The way we did that, if you see one of those prompts, which you will, okay, I would be beyond shocked if you didn't see something like that or very similar to that. Do your 4 quadrants in your paper, state, plan, do, conclude, and then fill in things as you know them. You may not know how to do all of it, but if you can fill in things somewhat, then you'll get some partial credit. Okay, so determine which test it is. Is it 1 or 2 sample? Is it a z, a t, or a chi-squared, which we talked about earlier? If it's chi-squared, which chi-squared is it? And if you get stuck, okay, if it's a hypothesis test and you get stuck, or a confidence interval, make up a reasonable value. If your 2 proportions look different, make up a low p-value. P is 0.04, okay? And then do, for your conclusion, since 0.04 is less than 0.05, we reject the null. There is reasonable evidence to believe blah, 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 okay? You can get a point for the conclusion even though you just made up a p-value. Hopefully you can get it in your calculator because that's probably the easiest point to get is the p-value and the t-score or z-score or chi-squared score. Remember, you put the hypothesis in the state position in the first little quadrant if it's a hypothesis test. So if it's that, do the data provide convincing evidence? Remember your conditions. Normal is large counts for proportion. You pool them if it's 2 proportions. Normal is central limit theorem for means. If it is an experiment, note random assignment, not just random selection. Don't just write SRS check. Quote the problem. If you always quote the problem, you're always going to be good on the random assignment versus random selected. Okay. And also, if it's an experiment, do not check the independence condition. They will count off if you check it. Learn that this week. And it's not RIN for chi-squared, it's RIE. So random independent expected counts. Okay, which generally comes from the calculator. Number 5 is, or not, I'm saying number 5, the 5th one is, it could be multiple pieces. Type 1 and 2 errors seem to show up a lot on the free response in those mixed portions. Remember hot hat. Type 1 is hot, the ho is true, but we rejected it. Type 2 is hat, the ha was true, but we failed to reject the ho, so we kind of sided with the null. Finding probabilities and then using that probability as kind of a faux p-value. Again, linear regression output, maybe using the p-value from a linear regression output to conclude. Know your interpretations. Making inference on data displays like, hey, there's this point down here on a dot plot. If that were your sample, how would that lead you to conclude about the true mean? Okay, kind of again leading into that p-value, that faux p-value. Investigative task. This is really the biggest thing with this problem. Don't stress if it doesn't look familiar to you. 2 years ago, my first year teaching AP Stats, my students freaked out because the problem was like 5 pages long. It had 1 page that was just a bunch of data, and they freaked out. And that's one thing I learned from that year is that it might not look familiar at all. Okay, it's a very long process. There generally are some things that are familiar, and that's how it was for that year. Like once my students kind of got into it, there were parts that they were super familiar with and they knew, and they were able to answer that pretty good. So don't stress if it doesn't look familiar to you. And I know it is graded worth more than everything else. But really, my goal is know the other things. Know the four big points we just talked about really well, and then you give yourself enough buffer zone. And if you know those things really well, the investigative task is going to come to you pretty clear too. Okay, it's aimed at you using your statistical knowledge to make good judgments on things outside the realm of AP statistics. Again, there's one part that's typically pretty good. Try to identify that at bare minimum, get that part done. Okay, I mean, you should definitely not leave anything blank. The free response, I think it was 2017 or 18. We did that as part of our mock exam at my school. It was on tortilla shells. And it was a long, drawn-out problem. But there was one part that was describe the sampling distribution. The mean was like 6, and it told you that in the problem. The standard deviation, you calculate it from the formula. The shape was approximately normal because the sample size is more than 30. Easy E, okay? And it was only a 3-part question. So 1E already bumped you up to a 1, and if there was a P somewhere else, then you were at a 2. And a 2 on the investigative task, you're in great shape. Okay? Here's the way that I would complete the order. Now, this is totally up to you, but here is my recommendation. Some students, and I was kind of this way as a test taker, I didn't skip around. If I skipped around, I would get stressed out on where to go next, and what if I forget to go back and do number 2, et cetera, et cetera. But if you need a strategy, I know in like ACT prep now they teach in English to pick one passage and do it. Pick like 2 of the 4 passages and do them really, really well, and then and spend like double the time so you can get to benchmark, and then any leftover time do the last 2 passages or something. I don't know. That's a bit beyond my understanding, beyond my pay grade, but somebody that I guess thinks they're smart figured that out and is telling people to do that. But here's my recommendation if you are one to skip around. I would do number 1 first. It's typically pretty easy, more familiar, get your feet wet. Then I would find the free response relating to inference, because you've probably spent a ton of time on that SPDC process, panic, phantom, whatever it is that you've done. I like SPDC. You got the 4 quadrants and do the 4 things. So identify that question. Number 4 seems to be the most likely, but it could be somewhere else. Okay, so identify that and work through that. Now you've got 2 problems under your belt. Okay, 2 problems. I think if you're studying and you're here on a Friday afternoon or watching the replay, you're probably pretty familiar with those 2 things, and you've got a good at least a 2 or a 3 on these 2 questions. You got a good footing to build on. So after that, I would go to the investigative task and spend 25 minutes doing that, and then go back and fill in the 2, 3, 5, 2, 3, 4, whatever those numbers are. Okay, if you were to want to skip around. Okay, some people suggest doing the investigative task first. I just don't think that's good for confidence because it's a booger. It's a tough one. I wouldn't want to start with that one. I would want to start with the other. If I were doing the test, I would just go straight through 1, 2, 3, 4, 5, 6. If I don't get to some parts on the investigative task, oh well. Hopefully, I knew what I was doing on the ones that are more predictable. But yeah, so if you do have any leftover time, go back to number 6. Read over all of them, okay? But you can go back to number 6 and really think more about the analysis part of it. All right, so that is it, okay? So some things that I'm going to... I forget about the online test. You have to answer them in order on the online test. You cannot go back. Don't agree with that at all. But very good point there in the chat. If you're doing the paper test and you are one that likes strategies and skipping around, that's the way I would do it. However, that's not the way I personally would do it, but some people, that's the way they learn, that's the way they test and are more proficient. So, yeah, online, not being able to go back is just silly to me, but I didn't make the rules. I just try to play by them and pretend I'm happy with them. All right, so hop on over to Discord, the AP Statistics channel. I'm going to post 2 documents that kind of sum up the slides a little bit. There's 18 very, very, very common free response questions, things that you might be asked that you can look at, make sure you're good. Like, oh yeah, I know how to do that. I remember him talking about that. I remember my teacher going over this, etc. And familiarize yourself with. Also, there's a list of 12 or 13 definitions you need to know how to interpret. Okay, and always all of them are interpreted in context. So I'm going to post those 2 PDFs so that you can access those from my Google Drive, and I'll make it so anybody can access it, and you can use those as sort of a little study guide. Okay, it's not like a note card or anything fun, but it is something you can look at. Okay, awesome. I hope everybody has a great weekend, and I will see everyone